All right, welcome to sprint number 3. We're just going to go ahead and jump right into this because it's going to be easiest to show this way. So, oriented bounding boxes, they're being visualized. They also collide effectively with each other. The line visualizer is, as you can see, a little bit off still. I didn't get a chance to go back and update those projections to face the correct way yet. But they helped me enough to figure out my collision issues. So the oriented bounding boxes collide effectively now. I also created the bounding box superclass. Um, there's some weird problems going on with it. I'll get to those later. First of all, regular old OBB here. Originally, I had all the collision data collected in the OBB specifically, and then I removed it out to be in the bounding box, so the code is a little messy here. But I'm leaving it for the time being. Like I said, there's some weirdness going on with the bounding box superclass. But the calculations are happening in the correct place. The half diagonal computed only once, the world matrix, the center, the scale factor, that sort of thing computed per frame. And then the collision right here, put together by collecting all the 15 testing axes, asking if they are free of a separating plane. Trivially true if the vector is 0 to deal with the cross product issue. So project the centers, get um, the distance between those. If the distance between the centers squared is greater than the distance of the diagonal projections squared, then there is a separating plane. And then the math for getting the diagonal projections is as listed in the PowerPoint. I'm using the absolute value version here, like I said, because I didn't get a chance to get the rendering pointed the right direction, and this is more computationally efficient. So yeah, as you can see, that works. It's linked in with bounding box as the general class. So I have, let's see here, yeah, the OBB, OBB, and OBB, ABB, AABB are still listed under here. That's to allow the three-way double dispatch pattern to still work correctly. The double dispatch pattern knows that they come in as their most specific types, and then it just loses some precision as it passes it back out. If I get the issue ironed out, then I can probably drop that back to just a two-factor double dispatch pattern. But I wanted to show you really quickly the issue that I'm running into. So for some reason, if I switch over the cottage to an AABB, I don't believe there's anything else that I need to change here. No, it just changes the bounding model from an OBB to an AABB. So the collision is no longer accurate. If I can adjust this correctly here. Okay, so you can see that I think the diagonal is somehow off on the AABB's test, because the projection is way longer than the actual bounding box should be. So it thinks it's colliding on a much larger area than the visualizer shows, which is unfortunate. But I can't narrow down the actual cause of that. So the ABB, like the OBB, is computing its collision values separately. Obviously, because an AABB uh, can change its min and max point dynamically. I believe the diagonal has to be computed here in the update. So we've got the world matrix. That's fairly straightforward. The half diagonal is also pretty straightforward, but I think is the issue. The scale factor still the same. The center point also fairly simple to compute. So I'm not sure why this is going wrong. Like you saw earlier in the math tools, the method is exactly the same for both of them. So it's clearly something wrong with the data. You just can't get it ironed out at the moment. One other thing that's weird and I can't get ironed out is, if you'll allow me to just a second here. Okay. In the update here. So I'm rendering a point 3 different ways using the colors here. You might have noticed that all of my boxes were black. It's a very weird situation that I've run into. So I'm rendering 3 points essentially on the same place here. The only difference between them is this one is explicitly defining the color vector to be 250 red. This is using my const helper function, I guess this is, that is, supposed to be able to name the color vector and return it. It's also 250. This one right here uses a member function of the frigate textured, just defines it as that, that helper function. So it is also red 250. But if I go into the game and look up here, you'll see that only one of them actually has any color. And that is the one that's the member function for no apparent reason. They should quite clearly all have the same color vector value. But if I just comment out the member variable, then there's nothing that's colored anymore, and I don't quite understand. So those are my issues. For the most part, it works, I guess. There's just some weirdness that I can't iron out because it's midnight and I need sleep. So that's it for this week.